All right, you guys. So this lesson is about linear equations still. So last time we talked about linear equations, but we talked about a specific form of a linear equation in slope-intercept form, and that was y equals mx plus b. Today we're going to talk about linear equations in point-slope form. And just like slope-intercept form is aptly named because it gives you the slope and the intercept, or y-intercept, point-slope is also aptly named because it gives you a point on the line and the slope. So here, what we're given is the x1, y1 is a point that is given in like the scenario, or maybe you'll be given a table, or you'll just be told an ordered pair, but the x value for that ordered pair and the y value for that ordered pair is going to be plugged in place of your x1 and your y1. For this, the plain x and the plain y are just going to get left alone, so don't plug any numbers in for those. Those are going to stay in your final equation, just like in y equals mx plus b, the y and x also stayed as variables. And then here, the m value means what it always has. That's going to be your slope. Okay, here's the deal. Most students are super comfortable and more familiar with slope-intercept form, but point-slope form is a lot of times a real time saver because it's not totally simplified, and it's an okay way to leave your equation if you're not told that you have to put it in slope-intercept form. So point-slope form is a good one, so don't shy away from using it. So let's talk about that really dumb cheer that I taught you on the last video. And it went like, if you want to graph a line beyond all compare, plot the y-intercept first, then rise and run from there. Well, here, we're just going to revise it because we're not given the y-intercept. So it's still the same, but you're going to plot the point given first and then rise and run from there, from, again, the point given. So let's do some of those. So for examples 1, 2, and 3, we're going to write the equation in point slope form, and then we're going to graph it. So here, the slope is our m value, and then the -5 here is going to correspond with our x1, and the 3 is going to correspond with our y1. So point slope form is y minus y1 is equal to m times x minus x1. So let's just plug numbers in. So the y is going to be left, the plain y gets left as y, minus y1, that's our 3, is equal to m, which is -2 times x, that stays a variable, minus -5. Minus and negative is the same thing as a plus, so you can say plus 5. All right, so here, if we were to graph this, what we want to do is we want to plot the point given first, which the point given is -5, 3. So -5, 3 is going to be right here. And then rise and run from there. Our rise is -2 and our run is 1. So from the point given, which is -5, 3, we're going to rise down 2 and we'll run right 1. Now we can connect our two dots with a line and extend it. And we've got our equation graph. Now I want you guys to pay attention to this. If you weren't given this information right here, you were just given the equation, you can tell what the point given is and what the slope is just by their positions. So this number in that position that's multiplied by that the two terms is always going to be your slope. And then your x and y, be really careful. It's always the opposite sign of that number. So here you could say that the point given is -5, and then it'll be the opposite sign also of that number because there's a minus in the actual formula. So think opposite signs on both of those. All right, so let's go on to the next. We've got our slope and our point. So our slope, it corresponds with the m value. And here's our x1, y1. So let's plug it in. Y minus, our y1 is 2, is equal to m, which is 1/3, times x minus -3. So that's going to make it an x plus 3. So now let's graph it. So we're going to plot the point given first. So -3, +2, and then rise and run from there. Our slope is 1/3, so we're going to go up 1 and right 1, 2, 3. And connect our dots with a line. Again, if you weren't given any of that information, you could see that the slope is that it's still a coefficient, and your point is, this is our x, it's always the opposite sign of that. So -3, and it's always the opposite sign of this, so 2. All right, now we've got a slope, that's our m of 5, and we've got the points -2, that's our x1, and -4, that's our y1. So let's write the equation. So y minus y1 minus -4 is +4 is equal to m, which is 5, times x, that stays a variable, minus x1 minus -2 is a +2. Now let's graph it. So -2, -4. And then our rise and run. Notice our slope is 5. That's a 5/1. So we're going to go up 5 and right 1. And we'll connect our dots with a line, and we've got our equation graphed. All right, so if I don't ask you for a specific form for the equation of a line, you can give me point slope form, and it's faster than slope intercept form because you don't have to solve for anything. You can just plug numbers into the equation. But sometimes I will ask you to convert those equations into into slope-intercept form. So what we're going to do is we're going to take those equations and we're going to convert them. So first, let's get them written down. So for example, and I call these example 1b, 2b, and 3b. So for example 1b, we're going to start with the equation that we wrote, y minus 3 is equal to a negative 2 times x plus 5. So here's what we're going to do is simplify like we did in the beginning of the year. So we're going to look for combining like terms and we're going to distribute. Here we have a number that we can distribute. So after we distribute that, we have y minus 3 is equal to negative 2x minus 10. And then remember, slope-intercept form is y is equal to, so we got to get y by itself. So I'm going to add 3 to both sides. The like terms in this are those constant terms. So we can say y is equal to negative 2x, and then we can combine negative 10 and 3 and get a negative 7. Now, if I drew my line really nice up here, you would end up seeing that my y-intercept would have been negative 7. All right, let's go on to example 2. So our original equation was y minus 2 is equal to 1/3 times x plus 3. And what do? We're going to simplify. So we're going to simplify by distribution here. And we'll get 1/3 x plus, remember this is 3 over 1. It's top times top over bottom times bottom. So 3 over 3, which reduces to a 1. And then y minus 2 on the left. Now we isolate y by adding 2 to both sides. And we get y is equal to 1/3 x plus 3. Notice our slope is 1/3. Our y-intercept is 3. And look, there's our y-intercept, and it is 3. And finally, our y plus 4 is equal to 5 times parentheses x plus 2. So what do? To convert this to slope-intercept is we're going to multiply the x plus 2 times 5. We'll get 5x plus 10, and then y plus 4 on the left. Now we're going to isolate y by subtracting 4 from both sides, and we get y is equal to 5x plus 6. And again, if I drew my line really nicely and neatly, my y-intercept, it looks like it's close to 6. All right, let's move on. Now, what if I gave you only 2 points on the line and I want you to write the equation in point slope form and then convert it to slope intercept form? So these will take a little bit of practice, but they're similar to what we did in the last video. So let's first look. This is our x1, y1, and here's our x2, y2. If we want to find slope, we need to identify an x1, y1, and x2, y2. So our slope is equal to a y2, which is 11, minus y1, which is 1, over x2, which is negative 3, minus x1, which is 2. So from here we get 11 minus 1 is 10, and negative 3 minus 2 is negative 5, and that simplifies further down into a negative 2. So now what we have is we have our m value, and we have 2 points, so we can choose one of the two. I'm going to choose this one because I don't like negatives. So now this becomes our x1, y1 in our equation. So let me rewrite point slope form without plugging in any numbers first. So y minus y1 is equal to m times x minus x1. And what do we put in place of y1? That number right there. So y minus 1 is equal to our m value we found was negative 2 times x minus x1. Our x1 is 2. So this is point slope form. If I didn't ask for a specific equation, you could leave it there. Since I did ask you to give me slope intercept form, I'm going to go ahead and distribute my negative 2 and get negative 2x plus 4, and then I'll add 1 to both sides and get y is equal to a negative 2x plus 5. And that's slope-intercept form. All right, next one, here's our x1, y1, here's our x2, y2. So we've got to find our slope first. So y2 is 10 minus y1 is 8 over x2, which is 6, minus x1, which is 4. 10 minus 8 is 2. 6 minus 4 is also 2. So our slope is 1. So now we can pick a point. I'm going to go ahead and pick my smaller numbers, and we'll plug into point slope form. So y minus y1 is 8 is equal to m, which we found was 1, times x minus x1, so minus 4. Now, we could say we're distributing a 1 over here, but it doesn't change anything. So we end up with y minus 8 is equal to x minus 4. Now we isolate our y value by adding, 8 to both sides, and we get y is equal to x plus 4. For our final equation in slope-intercept form. Again, if I just said write the equation, you could have left it like that original point slope form and it would have been a correct answer. Okay, next, here's x1, y1, here's x2, y2. So we've been given 2 points on the line. We're going to write the equation by starting off with point slope form, and then we're going to convert to slope intercept. So to find the slope, we do y2, which is 13, minus y1, which is 1, over x2, which is negative 3, minus x1, so minus a negative 1. Okay, so 13 minus 1 is 12, and then negative 3, this becomes negative 3 plus 1, so that's a negative 2, and that simplifies to a negative 6. Now, y minus y1. So both of these have negatives on them, so I'm just going to go with the point that has the smaller numbers. But I could have chosen this one, and it would have ended up with the same answer in the end. So here, y minus y1, our y1 is 1, is equal to m, which we found was negative 6 times x, minus x1. So it's minus a negative 1, and that's a plus. So we have y minus 1 is equal to negative 6 times x plus 1. And now we can convert. So negative 6, if we distribute that to both terms, we get negative 6x minus 6 is equal to y minus 1. Now we add 1 to both sides, and we get y is equal to negative 6x minus 5. So point slope form would have been that, and slope intercept form is that. All right, let's go on to example 7. We're going to do a practical scenario and talk about how point slope form applies to practical scenarios. So Connor loves to attend concerts. He even bought a vintage leather jacket to sport every time he attends. If he spent a total of $600 after attending 10 concerts and $1,200 after attending 25, how much did he spend on average for each ticket, and how much did he spend on the jacket? Tell me everything you can regarding the algebraic scenario. So, or the algebraic concepts in the scenario. There's a ton of things that we could talk about and apply to the math that we're learning. So the first thing we want to do usually is identify our variables. We'll look at what's changing. Look at how, do you see that second sentence or third sentence where it says he spends $600 after 10 concerts, $1,200 after 25. So the things that are changing is how much money he's spending after how many concerts he goes to. So here's where you're going to ask yourself, do the concerts depend on how much he spends? Or does how much he spends depend on the number of concerts he goes to? Hopefully you thought that first one didn't really make a whole lot of sense. So notice here, how much spent depends. So that means that the amount of money he spends is our dependent variable, and the number of concerts is our independent. So number of concerts, and I'm going to abbreviate that to independent variable, and the amount of money is our dependent variable. So what we have here when we see 600 and 10 and 1225 is that we have two ordered pairs. And think about this. The number of concerts is our x value, and the total cost is our y value. So what we can do is we can say after 10 concerts, he spent $600. And after 25 concerts, he's spent $1,200. So notice now we have a mathematical scenario with some ordered pairs that we can use to tell us a lot of things. So we've talked about independent, dependent variables. Let's see if we can get an equation from this scenario. So if we have two ordered pairs, just like in the examples above, we can write the equation for those scenarios. So what we can do is we can find our slope. We can call this our x1 and our y1. This can be our x2 and our y2. So we can say 1200, that's y2, minus y1, which is 600, over x2, which is 25, minus x1, which is 10. So 1200 minus 600 is 600, and 25 minus 10 is 15, and this gives us 40. All right, so now let's use point slope form to write an equation for the scenario. So we can say y minus y1. Let's just use our smaller ordered pair. You could use the other one and it would be fine, but we're going to use that top one. So we can say y minus 600 is equal to m, which we found here, so 40, times x minus 10. If I just asked you to give me an equation for this scenario, then you've got it. Now, if I asked you to tell me something, which this is actually stated in the question, how much did he spend on average for each ticket and how much did he spend on the jacket? Well, it's more helpful to go ahead and convert this to slope intercept form. So let's do that. We're going to distribute the 40. So y minus 600 is equal to 40x minus 400. Now we can add 600 to both sides. And we end up with y is equal to 40x plus 200. Now, why is this helpful? Remember, how you can connect slope and intercepts with practical scenarios. So remember, the slope is our rate, it's a per. And I want you to think about this. The thing that he's having to pay for over and over and over is the concert tickets, right? So what that 40 tells us, the over and over and over number, is our slope. And in this case, it is the cost on average per ticket. Now let's talk about that 200. 200 is the number that he just paid once. It's like before he attends any concerts at all, he already spends $200. Well, what did he spend money on that wasn't tickets? Well, it was that vintage leather jacket. And we just were able to identify how much it cost. So this $200 is the cost of the jacket, which is super helpful. Now you've got some more information about the scenario. Okay, let's see if we can graph this. So we know that the slope is 40. And so we probably want, so think of it as 40 over 1. Remember, the top number is going to correspond with our y values, and the bottom is going to be our x values. So let's go ahead and just count by ones on the x-axis. Remember, this is the number of concerts. Now, here's the deal. He already at the very, very beginning, but before he goes to any concerts, he spent $200. So I'm going to actually add a break in my graph, and I'm going to start right here at 200. And then after that, I'm going to start counting, let's say count by 20s. So let's say this is 220, here's 240, here's 260, here's 280, and we can go on. So every box there is going to correspond with $20. So remember, what does our y-axis represent? Well, that's his total amount that he's spent. So let's say total spent. And now we can graph it. So at 0 concerts, he had to buy his jacket. After 1 concert, he's spent $240. After 2 concerts, he's spent another $40. So that's $280. After 3 concerts, he will have spent $300, and so on. Okay, so we can continue that pattern until we run out of room on our graph. Now, the question I would ask is, should we connect the dots? So what you want to ask yourself is, like a point here, for example, that would be a point that would mean like 0.5 concerts, and he spends $220. And hopefully you're thinking in your head that that doesn't make sense. He can't attend half a concert or pay for half a concert. So at that point, that makes this scenario discrete. So if we were to do the domain and range, then discrete graphs have a domain and range that are lists of numbers. So you want to think about what's the least, remember what domain means. Domain goes with x, and our x is the number of concerts. So he could have bought the jacket, but then not gone to any concerts. Or he could have gone to 1, or he could have gone to 2, and the scenario doesn't give us an end value. So we can just say ... And then for the range, think about this. Before he goes to any concerts at all, he's already bought the jacket. After he goes to 1 concert, he spends $240. After he's gone to 2 concerts, it'll be $280. And we are talking on average here. I know that some concerts cost more or less than others, but in this scenario, we're talking about, well, if we were to average all the costs out, about how much would he spend after each concert. So now I think we've pretty much gone through everything we can regarding the algebraic scenario, except maybe let's change this and write it in function notation. And now I think we've done everything. All right, see you guys next time.